Today we're going to learn about polynomials. A polynomial is made up of terms that are only added, subtracted, or multiplied. Polynomial, the word, comes from poly, meaning many, and nomial. In this case, meaning term. So it means many terms. For example, this expression has 3 terms. For example, 1 term, 2 terms, 3. So those are our terms, all separated by our operation signs. A polynomial can have constants. Those are the numbers that go before the variable, like 4, 3, or any of those numbers. A variable or many variables. Those are the letters we use, like x and y, and exponents. Like, for example, the 2 in our expression above. And polynomials can be combined using addition, subtraction, and multiplication. But not division. In these examples here, these are polynomials. And these are not polynomials. Notice that has a negative exponent. That is not a polynomial. And this is a division, so that is also not a polynomial. There are special names for polynomials. With terms like 1 or 2 or 3 terms. There are other names for 4 or 5 more, but those are most not commonly used. For example, 1 term, the special name is a monomial, like a motorcycle or a monocle. 2 terms, the name is a binomial, like a bicycle with 2 wheels. And 3 terms is a trinomial, like a tricycle. You can also think of biplanes, things like that. Polynomials are also put in special order with degrees. The degree of a polynomial with only one variable is the largest exponent in that expression. So, for example, in our expression 4x cubed minus x plus 3, the largest exponent is this 3, this cube. So the degree of this polynomial is 3. In another expression, 5x to the 7th power plus x squared minus x plus 1. The largest exponent in this expression is 7. So the degree is 7. So you see, degrees are just basically taking the exponent, finding the largest one, and that's the degree of that polynomial. Polynomials are also written in standard form. The standard form for writing a polynomial is to put the terms with the highest degree first. So I'm going to write here, put the terms with the highest degree first. So, for example, let's put this expression in standard form. We have 3x squared minus 8 plus 2x to the 3rd power or cubed plus x to the 7th power. So in this expression, our largest exponent is 7, so that one will go first. So x to the 7th power, and then we look and we go, okay, the next one is the 3, the cubed. So plus 2x to the 3rd power or cubed. The next exponent is the squared, so, or the 2, 3x squared, and then we put our 8. So that expression or that polynomial is now written in standard form. To simplify polynomials, we simply combine like terms. So I'm going to write here, combine like terms. What does that mean, a like term? I like to think about the letters using different words or different expressions. So, for example, in this expression, x squared plus 3x plus x squared plus 1 plus 2x, I like to think about those x's as different things. Let's think about the x squared as x-rays and the x as xylophones. So I'm going to combine my like terms, and the way that I like to start out by doing that, I put different things around it. So I'm going to put triangles around my x squares, and I'm going to go back and put squares around my x's, and then I'm going to put circles around my numbers. So now I just combine the things that I have put together that are alike. So I have 2x squared, or 2 x-rays, plus I have 3 xylophones, plus 2 xylophones, so we have 5 xylophones, and then we just have our 1. So that is how I like to combine like terms. Let's try another one, and then you will try it also. So we have 7x minus x squared minus 5x plus 3x squared. So I have some x-rays here, so I'm going to put triangles around my x-rays. And I'm going to put squares around my xylophones. And notice I'm getting the sign that's to the left of them also to go with it. So I have, how many x-rays do I have? I have 3x squared x-rays, and then I have a negative x-ray. So I have 2x squared, remember our integer rules. And then I have 5 xylophones. I have negative 5 xylophones and 7 positive xylophones, so I have 2 xylophones. And I don't see any numbers in this expression, so I have 2 x-rays, or 2x squared, plus 2 xylophones. Now, I cannot combine my xylophones with my x-rays, so that is as far as I can go. So think of it in terms of that. When you have letters, give them words or names. Now, you try by combining these like terms in this expression. So here is your problem that I'm writing down. Negative 2 minus 2x minus 2x squared plus 3x plus 3 plus 3x squared. So you can pause the video here and try to figure out how to solve this problem by combining like terms, and then we'll come back and talk about that. Okay, so hopefully you have tried to do that. So let's do what we were doing before by using our triangles and squares. So I'm going to put the triangle over the x squared, or my x-rays. I have what looks like 2 of those. I'm going to put my square around my xylophones, along with the operation that's next to it. And then I'm going to circle my numbers. So I've got everything taken care of. Now I'm going to go and combine the items that are the same. So I've got a positive 3x squared and a negative 2x squared. So that, in my integer rules, equals 1x squared. Then I've got negative 2x's, and I've got positive 3x's. So that's plus an x, or 1 xylophone, or x-ray, whatever you're calling it. And then we've got plus 3 and negative 2. So that's plus 1. So we have combined our like terms. Okay, I'm going to give you a challenge question here at the end, but I know many of you are asking right now, why do we need to use polynomials? What are they for? So why polynomials? Well, you know, the teacher, they always say to pass the next test or whatever, but polynomials are basically models of things that exist in 3-dimensional reality. So you're going to get used to using those in your calculus classes. But when we look at polynomials and we take apart the expressions, polynomial factoring allows you to look at the expression, study its characteristics, and attempt to unravel its components, or what makes it up. It is an analysis. We're analyzing these problems, these expressions, and you're learning a pattern of thinking to prepare you better for algebra. So that basically is what polynomials are. So I'm going to put the challenge question down here, and you can come into class with this challenge question figured out, and we'll see how you do. So here is your challenge question. Negative 3x cubed plus 2x minus 9xy minus 2y to the 5th plus 1 minus 4y squared plus 5yx plus x cubed minus 6y plus y to the 5th power and z to the 5th power. So go ahead and combine those like terms and come into class with this challenge question completed, and realize that learning polynomials can be fun if you just remember some of the rules.